So guys, now next let us discuss what is page table. So page table is a data structure which is maintained by operating system for every process that is running in the system. Remember, page table is for every process. That is, every process has its own private page table. Page table is used to map the virtual address of process virtual address space to a physical address in RAM. So let us see the contents of page table and how does it help to map the virtual address in a process virtual address space to a physical address of RAM. So let us suppose that following represents the virtual memory of some particular process. Let us say that this virtual memory of a process is fragmented into 5 virtual pages. And the diagram on the right hand side represents random access memory, that is physical memory, which is splitted up into 7 frames. So this is a physical memory, and we already know that physical memory is a non-contiguous memory. Non-contiguous here means that physical pages of a process which are contiguous need not be present in adjacent frames in this main memory. So you can see that the physical page P0 is present in frame F3 and physical page P1 is present in frame F5, and frame F3 and F5 are not adjacent frames. It is for this reason that physical memory is called non-contiguous memory. Whereas virtual memory is called contiguous memory because virtual pages in this virtual memory has to be strictly laid down in the ascending order. Now let us see that where does the page table fits. So you can see that page table is like a marriage maker between virtual memory of a process and the physical memory. So page table contains 3 columns. The first column is the virtual page number of a process. The second column is the corresponding physical page number to which this virtual page number maps. And the third column is the frame number. So in this example, the virtual page number 0 maps to the physical page number 0 of a process. Similarly, virtual page number 1 maps to the physical page number 1, and so on. So in normal scenario, the virtual page number is always equal to the physical page number. We will see later that in what scenario virtual page number may not be equal to physical page number in a page table. And the third column is the frame number. Frame number means the frame number of a main memory in which this physical page is loaded. For example, physical page number 1 is present in frame number 5 of physical memory, right? So you can see that physical page number P1 is present in frame number 5 of physical memory. Similarly, physical page number 2 is present in frame number 1 of physical memory. So here you can see that, right? So we use the page table to know that corresponding to a given virtual page number, a physical page number is loaded in which frame of a physical memory. For example, in order to do a lookup into this page table, we will supply virtual page number as a key. So suppose the key supplied is 4. So corresponding to the virtual page number 4, the physical page number is 4. And the physical page number 4 has not been assigned any frame number in the physical memory. It simply means that physical page number 4 is present on a disk instead of main memory. And remember, we already know that corresponding to every virtual page of a process, there exists a corresponding physical page. Now, I ask you one question. What are the number of rows in the page table? Right? So the number of rows in the page table must be equal to the number of pages in virtual memory of a process. Number of virtual pages in a process virtual address space is 2 raised to the power 20. So it means that number of entries in a page table is equal to 2 raised to the power 20 on a 32-bit operating systems. So number of rows in a page table is equal to number of pages in a process virtual address space. right? And this makes sense because the key to the page table is the first column, which is virtual page number, right? And the maximum virtual page number is 2 raised to the power 20 minus 1. Now let us take an example to illustrate how address mapping from virtual address to physical address happens. I hope I'm able to explain that what is page table and how does page table help us to map a virtual page to a physical page, and how does page table help us to find out that a given physical page is located in which frame number of a physical memory. So from this page table you can immediately say that if I give you an input as virtual page number as 3, so you should be able to say that virtual page number 3 maps to a physical page number 3, and this physical page number 3 is present in frame number 2 of a physical memory. So you should be able to read the meaning of a particular entry in a page table. Again, by default, virtual page number is always equal to the physical page number in a page table. When we shall be discussing the advanced concepts such as shared memory or forking, then in those scenarios we will see that virtual page number may not be equal to the physical page number in a page table.